Okay, so this video is about how to determine how many atoms there are in a compound. So a few things that you need to know. First is something called a coefficient. The coefficient is that big number that's in front of the compound. Next, you'll notice these little teeny tiny guys. Those guys are called subscripts. There's two types of subscripts you can have. The first is one that's directly attached to an element symbol. So for example, Mg3 would just say that there's 3 magnesiums. And there's also little subscripts that are outside of parentheses. And the thing that you need to know about those subscripts that are outside the parentheses is it's saying that there's, for example, right here, PO4 parentheses 2, that there's 2 PO4s. So really that 2 distributes both to the O and to the P. Okay, and then these big coefficients, just like in math class, are going to distribute to everybody that it's in front of. For example, in math class, if you had something like this, really this distributes to both, and it's really 2x plus 10. So, in this case, what you're going to do is you're going to multiply, to figure out how many atoms there are of each element, you're going to multiply the little subscript that's actually touching the element times the parentheses subscript, if there is one, and then times the coefficient. So everybody is affected by that big coefficient, and that is going to have a very big impact when we're dealing with balancing chemical equations. So let's look at number 1. For magnesium, we're going to say, okay, magnesium has a little 3 subscript, so we know that first we're going to start with 3. There is no parentheses around the magnesium, so we don't need to worry about any subscripts outside of the parentheses. And then we know that there's this big coefficient right there of 3, so really there's going to be 9 magnesiums, because 3 times 3 is 9. Phosphorus, we're going to say, okay, technically there's no subscript that we can see right there, but because we're lazy, we know that really it just means a 1, that there's 1 P right there. Then we know that because P is inside of those parentheses and there's a little 2 subscript outside of there, we're also going to multiply by that 2. And then we're going to multiply by the big 3 up there because everybody gets affected by that coefficient. And this becomes 1 times 2 times 3, which is 6. Finally, if we look at oxygen, oxygen has a subscript attached to it that is a 4. It's inside of parentheses that has a 2 subscript outside of it, so it's affected by that subscript. And then obviously it is affected by that big coefficient. So it'll be 4 times 2 times 3, which ends up being 24 atoms of oxygen. I'll try just a couple more examples really quick. For this one, we have carbon, hydrogen, and oxygen. There's no parentheses in this one, so we can skip the parentheses step. So for carbon, we're going to have 2 subscript times 2 coefficient. Hydrogen, technically, look, we have 6 hydrogens here. They can basically be counted as if this was H6 because there's no subscripts there outside of parentheses that would make it have a problem like that. So we can just say 6 times 2 is 12. Because really what we're doing is 5 times 2 plus 1 times 2. And then finally, oxygen, there's a secret 1 right there, so it would just be 1 times 2, which is 2. And then finally, this last one, we're going to say aluminum, sulfur, and oxygen. Aluminum starts with 2, there's no parentheses there, but there is the big coefficient, so that makes 6 aluminums. Sulfur, there's technically a 1 right there, times the 3 outside of the parentheses, times the big coefficient, so that makes 9. And then oxygen has 4 times that 3 times that 3. So 4 times 3 times 3 is 36. Total atoms of oxygen within that compound with the coefficient.